Hi class, we're now on 11.3. This is pressure, just discussing pressure and the result of constant molecular collisions. So pressure, again, as I discussed in the previous section, is the result of constant collisions between atoms or molecules in a gas and the surfaces around them. The more collisions, the higher the pressure. Because of pressure, we drink from straws, inflate basketballs, put air in, move air in and out of our lungs. We can add air into a tire on a bike, and so forth. Variation in the pressure in the atmosphere creates wind, and these changes in pressure help predict weather. So if you ever watch the news, sometimes they'll say high pressure system, low pressure system. These are some of the things that they're talking about. So pressure is around us and even inside of us, which I didn't discuss yet. We have pressure that's built up inside of us that actually exerts out. So we have pressure that's we're being hit constantly by molecules, but we also have pressure built up inside us that's giving pushing up against us as well inside. So as we climb a mountain or ascend an airplane, there are fewer molecules per unit volume in air, and the pressure drops. So this is when you're on a plane, you start feeling your ear drop, popping. So the external pressure drops while the pressure of the air within your ear cavity remains the same. So that's creating that imbalance, and that's when you start feeling your ear popping, or it feels like it's plugged up. That's because of the pressure difference that's going on. Eventually, it will equalize, and that pain and that uncomfortableness goes away. So let's look at pressure. Pressure is equal to a force over an area. So what that means is, if you look at this, is in this box here. This area is where this rectangle or square is here, where the X, and it's the amount of force that's being pushed in this direct area. That is what pressure is equal to. So that results from the collisions of the gas particles that are with the surrounding surfaces. The pressure exerted by a gas depends on several factors, including the number of gas particles in a given volume, which definitely will affect it, because the more molecules there are, the more collisions there will be, the higher the pressure. The less molecules, the lower the pressure. So since pressure is a result of collisions, this is exactly what I was stating. So if we look at these containers, there is a lower pressure when you have less molecules. So there's less collisions, there's less pressure that's building up. But when you have higher pressure, this is because you have in this case, you have more molecules, so they're colliding with each other. They're also colliding with the surface, and they're more compressed. There's not as much empty volume between them as there is here, so they are interacting with the surface and each other more, which results in a higher pressure. So we're going to start looking at units. So the simplest unit is atmosphere, and that is ATM. That is the units that we use. The shortcut for it, abbreviation, is ATM. And that is the average pressure at sea level. So 1 ATM equals what we consider sea level. The SI unit of pressure is Pascal, and it's capital PA, and that's defined as 1 Newton meter squared. So remember, pressure is force over area. So 1 Newton is the force, and meter square is the area, and that equals a pressure of 1 Pascal. The Pascal is a smaller unit. 1 ATM is 101,325 pascals. Let's just make it easy. And that is equal to 1 ATM. However, I'm going to show you other units for pressure as well. So we also use millimeters mercury. Why mercury? Because there is a barometer. We can use a barometer. And a barometer measures the pressure exerted by the gas in the atmosphere. So now if you look at your phone, you can it's digital. So if you look at the weather, if you go down and slide down, you can see what the pressure is in inches mercury. This is millimeters mercury. And this is how they used to determine the pressure way back in the day. This is called a barometer, and there is mercury in this. So that's where the millimeters mercury comes from. And this mercury, so what happens is that this pressure that's equal here is equal to 760 millimeters mercury. And so this pressure here is open to the atmosphere, and the pressure will push down on this mercury that's in this barometer, or the pressure will be lower pressure and it will not push down on it as much. Here, it will either affect what's in here. So think of a straw. It will either affect what's in here, or it will also reduce that volume. And there is no air particles. When the mercury is filled with this, there is no air particles. So that's how we're able to determine if this volume of mercury in here is moving or changing. And So basically what this means is this downward pressure on the mercury is the same as the pressure of the atmosphere. And that's how you're able to determine what the pressure is for that day, by the changes of what you see of the height in here. But 760 millimeter mercury is also equal to 1 atm, which is also equal to another pressure unit, which is 760 torr. So these are all pressures that we can use for conversion, is where this is eventually leading. This is a slide that was given to me. This is the same thing that's stating the average atmospheric pressure at sea level of a column of mercury is equal to 760 millimeters mercury, which is also 1 atm. So these are all equivalent to each other. Mercury is 13.5 times as dense as water. So it's pushed up 1 of a 13th times as high as water. So if we were to use water, water is not as dense as mercury is what it's saying. So we would have a larger barometer, and the height of this would have to be way bigger in order to accommodate the water and how less dense it is. Remember, density is how condensed something is, how packed in the molecules are. Water is not as condensed as mercury. So that's what it's saying. The column would have to be 13.5 times higher than what it is with mercury. So I discussed units, and here we're coming back to units. So this is all, so 1 atm is equal to 760 millimeters mercury. It's also 1 millimeter mercury is equal to 1 torr. Why is that? Because 760 millimeters mercury is equal to 760 torr. So these two are equal to each other. So that's where this ends up coming up. These, however, are not equivalent to 1 atm and 760 millimeter mercury. They're just showing that the increments are the same here. If you wanted to have the same 1 atm, then it would be equal to 760 torr or millimeter mercury. And that 1 atm is also equal to 29.92 inches mercury, and 1 atm is also equal to 14.7 pounds per square inch. So this is the table that's given to you in your, well, I think you have an ebook. Some of you guys may have the book. And these are all equivalent to each other. I don't like how they set this up. It's not as clear. This is from another section I teach, and they kind of have it more equivalent, where it's clearly labeled here. So you can see what this means is that units equivalent to 1 atm. These are all equivalent to 1 atm. So I tried to spell it out here so you guys can see. I didn't finish the rest of them. But all of these are equivalent to each other. So if you need to do conversions, which we will be doing, this is handy to understand these units. All right, so again, let's do a conversion problem. So convert 0.311 atm to millimeters of mercury. So we know that the conversion of 1 atm is equal to 760 millimeters mercury. So we need to get from atm to millimeters mercury, and we need to do an equality in order to set that up. So we do set that up with our conversion, and we have 0.331 atm. 1 atm is on the bottom, 760 millimeters mercury on top. This equals 236 millimeters mercury. There's 3 sig figs, 3 sig figs. These are equivalent to each other, so we are going to only look at these here. All right, so what is 475 millimeters mercury expressed in atm? So again, here is the conversion, and I'm just going to jump to the answer so you can see how we set this up. 475 millimeters mercury, we use the conversion factor, and that equals 0.625 atm. So the answer would be B. Now the pressure in a tire is 2 atm. What is the pressure in millimeters mercury? So I hope you're seeing that there's a trend here. As long as you know the conversion, it's not any different than what we've been doing. We are just using pressure in this case. And this is 3 sig figs, this is 3 sig figs, 3 sig figs. We're not counting this. Okay, so the downward pressure on the mercury in a barometer is greater than, less than, or the same as the pressure of the atmosphere. And it would be C. It is the same. That's how they're able to determine the pressure. If there's even slight changes in this from where the 760 markings would be, then they know that it's either going above, then there's higher pressure, or there's lower pressure, depending on how much this is pushing. Because if it's pushing, it's going to push it up. And if the pressure is lower, it's going to let this go down. So they can determine what the pressure is. Now, a water, I already gave the answer. I forgot they were on the same thing. A water barometer is 13.6 times taller than mercury. So let's see, because water is less dense than mercury. So remember, you'd have to have a larger column and a larger barometer for water over mercury, because mercury is so dense compared to the density of water.